We got some more. This one actually isn't too bad. It sounds worse than it is, I guess. So if you wanted to mix pure methane with water and end up with 80 gallons of 45% methane, how many gallons of each should you use? See, and this is where my math nerdiness comes into play. I thought methane was a gas, but it's making it sound like we're mixing two liquids. So if I'm wrong, don't correct me because I want to feel good about myself. Actually, I wouldn't care.
I thought methane was a gas.
I wouldn't care, but so apparently this is a pure methane is a liquid. But I feel like I'm already getting into science nerdiness, and that's a whole different type of nerd. We don't like those types of nerds. We don't care, of course, but I have to say that as a math person. Okay, so we want two equations, right? And the two things we got right here is we got the methane and we got the water.
Correct, it is a gas.
Yes, except I am able to express gallons of water in methane. Because water, as it turns out, is, again, this is my limited knowledge, it's 0% methane. Now I want to do the equation this way because it makes me feel better. Does that mean you can't, does that mean you have to do it this way? No. Okay, so here's my equation. Just for the methane, it's 100%, so I'm going to show that as 1.00 times the amount of pure methane that we're putting into this mix. Okay, the water, on the other hand, is 0% methane, and since I'm comparing it with methane, I need to multiply it by m. Now that may seem weird, but it's going to do something magical for us. And by magical, I mean math nerdy. So the 45% methane, though, of course, that's a 0.45. And it did tell us as well that it wants that to be 80 gallons. So I'm going to have to multiply that by 80. So let's rewrite this equation. But all I mean by that is I'm going to take the 0.45 and times 80. So 0.45 times 80, enter, and that would be 36. Okay, so the new equation, I'm going to rewrite it this way. Okay. In fact, from here though, let's figure out, because that's based off of the percentage of methanol. Okay, so we know that that equation is the percentage of methanol. So I'm going to label that equation in percentage. But we can also find the equation based off of, what is it, the gallons of methanol. There we go. So, how many gallons of methanol? Well, you got methanol, and you could even say add that to the amount of water that you have, and that would give you the mix, which would be 80 gallons. Which may be something to keep in mind. I know this top equation right here is written in just in methanol. That's okay, right? Because water is just 0% methanol. But we need this equation, not necessarily, but mathematically we can say that we need it. Here's what I mean, is when I solve for the methanol, which I will do up here, I could just take the mixture volume, 80 gallons, and just subtract whatever I find for the methanol. So what is the methanol? Well, as it turns out, this part of the expression, 0.00 m, that's just 0 right there. I can actually zero that out, and what I end up with is this equation. 1.00 m equals the 36. Okay, what this tells us is that's all the methanol there is. The methanol, 100% pure methanol, that's 36, and that was gallons of methanol. Okay, so that's, I'll put gallons right there. In fact, I'll say of methanol. So 36 gallons of methanol, but we know that the total mix is 80. So if I want the amount of water, I can just take the 80 gallons total, subtract the 36 gallons of methanol, that's a 6 by the way, and I end up with 44. Okay, so that's the amount of water that I have. Let's go and label that. That's gallons of water. So that's both the values that we needed. We now know that there are 36 gallons of methanol, and then down here in the bottom right, there are 44 gallons of water. Now again, you can check 1 times 36 plus 0 times 44, really 0 times anything equals the 36. And then down here, the methanol plus the water, 36 plus 44, boom, 80. So it checks out both ways, and we have our answer there.